Good day and welcome back for the fourth and final installment on related rates. As indicated multiple times in the past videos, related rates are really a type of problem that you need to sit down and put time into practicing. At the end of the last video, we mentioned there's an associated worksheet that you can find in Canvas, and for this video, I'd like to go over problems 3 and 4 from that worksheet. So problem 3, we are given the following information. A Ferris wheel 50 feet in diameter revolves at the rate of 10 radians per minute. So we have a person on the Ferris wheel, they're going around it at 10 radians per minute. How fast is that passenger rising when the passenger is 15 feet higher than the center of the Ferris wheel and rising? So I have a rough picture sketched. Let's add in a few more key details. We're told that the individual revolves around at a rate of 10 radians per minute. So that's indicating that the angle theta, formed as we see in the picture, is going to be increasing at a rate of 10 radians per minute. Furthermore, what we are asked is how fast is the passenger rising when he or she is 15 feet higher than the center. So we also need to measure the height of the individual relative to the center of the Ferris wheel. So that would be the distance from the individual to the center line of the Ferris wheel. We'll call that h. So from the information that we are given, we know d theta dt is equal to 10 radians per minute, and what we would like to find is dh dt when h is equal to 15. And I want to be once again as clear as possible when it comes to doing any of these related rates problems on homework or exams. I need to see all of this information. A picture with each quantity changing with respect to time properly labeled, the rate of change you know, the rate of change that you're going to find. So remember, if you do not have any of that information, you will have some type of point deduction associated with it. Those are the things at a minimum I need to see in terms of your setup. Then moving on, we need an equation relating theta and h. And note, in our picture, we have a right triangle, and we know the length of one of the legs and the hypotenuse. So in this case, the desired trig function is that sine of theta is equal to h over 25. And as usual with these related rates problems, now that we have this equation relating those two quantities, this is when we get the calculus involved. We differentiate both sides implicitly. So on the left, we would have cosine theta and then d theta dt because it's implicit. And on the right, we would have 1 over 25 times dh dt. And we're in an ideal situation. We would like to find dh dt, and in order to isolate it, we can simply multiply both sides by 25. So 25 cosine theta d theta dt. And what we want to know is what is dh dt precisely when h is equal to 15. So working from left to right, the 25, we have that no problem. Cosine theta, that's going to need a bit of work. And d theta dt we know immediately is 10. And recall, as we've seen previously, when it comes to substituting in this specific value, there may be some additional work involved related to either that equation we started with or our picture. And in this case, I think going back to the picture is probably the easiest thing. We have a right triangle, an angle theta. We know the hypotenuse is 25. And what we would like to know is what is cosine of theta when h is 15? And we could certainly use the Pythagorean theorem, but note just from the proportions that we have, 15 and 25 are both multiples of 5, so this looks like it should be a 3, 4, 5 right triangle, which would indicate that this bottom leg is 20. Cosine of theta, in this case, will be 20 over 25. And note this simplifies quite nicely. The 25s cancel. What we are left with is just 20 times 10, and then we need to get our units in, dh dt. H has units measured in feet, because we're measuring distance, and our time is measured in minutes. So dh dt will be 200 feet per minute. Let's move on to problem 4 in the worksheet. So let's just read through the problem and see if we can add into our picture that we have going. 2 trucks, one traveling west, the other traveling south, are approaching an intersection. We're going to assume that both of the vehicles are traveling at a rate of k kilometers per hour. And what we would like to determine is how fast are they approaching each other when they are m kilometers from the intersection. So let's get a little more information in. So I'm going to let in each case kind of just a dot represent the location of the car. In the problem statement, we are told that the vehicles are traveling at k kilometers per hour. So for example, if I let x represent the distance the car traveling from the west is away from the intersection, and if we let y represent the distance that the car traveling south is away from the intersection, what we know is that dx dt is equal to dy dt, and in this case they're both going to be minus k kilometers per hour. And I want you to take a moment and think why I would say they are minus k kilometers per hour. And the reason I'm saying a negative is x and y are measuring in our picture how far the car is away from the intersection, and that quantity is decreasing as a car approaches the intersection, hence a negative rate of change. What we would like to find is how quickly the cars are approaching each other. So if those blue dots represent the positions of the cars, we could connect those dots and say z represents the distance between them. And what we want to determine is what is the rate of change of that distance between them precisely when they are both m kilometers from the intersection. So that would be when x is m and y is m. So now we have our generic setup, a picture, what we know, what we would like to find. What we now need is a relationship between these quantities x, y, and z. And similar to other problems, there's a key geometric relationship for the lengths of the sides of a right triangle. The Pythagorean theorem tells us immediately x squared plus y squared is z squared. And differentiating implicitly, we have on the left, working from left to right, 2x dx dt plus 2y dy dt is equal to, on the right, 2z dz dt. And immediately we can go ahead and just say, how about we divide every term by a 2, and we can cancel those off. And now, solving for dz dt, we would have it isolated if we divide both sides by z. So we have what was on the left previously, x dx dt, plus y dy dt, and we're dividing it by z. And what we would like to find is what is dz dt when x is m and y is m. So let's just go ahead and start substituting in values and see where we are at. So working with our numerator, x is m, dx dt is minus k, y is m, dy dt is minus k. The only quantity that we really need to determine here then is what is z. And if we know x and y, we can use the Pythagorean theorem to determine z. And this is just once again kind of a side computation. So note, from this relationship, x squared plus y squared equals z squared, we have m squared plus m squared is z squared. So 2m squared is z squared, which means z is equal to plus or minus the square root of 2m squared. And because z is representing a distance between two vehicles, it has to be positive. So in this case, we would have the square root of 2 times m. And if we substitute that in for z, what we end up with is dividing by square root of 2 times m. And the units that we have for a rate of change of distance with respect to time in our problem is in kilometers for distance, hours for time units. And note, we can do a couple cancellations here immediately. Each and every term involves an m, so those all cancel. In the top, we have minus 2k square root of 2. And if for fun we multiply by 1, in this case root 2 over root 2, what we'll be left with is a minus 2k root 2 over 2. And we have the desired quantity now. dz dt is equal to square root 2 times k, with a minus sign, kilometers per hour. Which is exactly what we were asked to show. That is that the two vehicles are approaching each other at a rate of root 2 times k, kilometers per hour. And we have the negative sign in here because the distance between the two cars is getting smaller, indicating a decreasing quantity and hence a negative rate of change. So I'll just put a check mark. Yes, we've shown exactly what we set out to show. So as usual, make sure you continue on practicing. When you complete the first two problems on the worksheet, check your solutions versus the solutions I have posted on Canvas. If you have any questions at all, do not hesitate to reach out. So stay tuned and take care.